Hi scientists, I'm Ellie,
And I'm Brian.
and welcome back to another demo of the week.
Today we're going to discuss the reactions of endothermic and exothermic reactions by showing our thionine reaction, which is a endothermic reaction.
Before we get into that, let's do a quick review of redox reactions.
Reduction and oxidation requires a transfer of electrons. A reduction is the gaining of electrons.
When something's being oxidized, it's losing electrons. So in this reaction, thionine's gaining electrons from iron, meaning it's being reduced.
Okay, so why are endothermic and exothermic reactions important here? Well, as you can see here with endothermic reactions, energy is required to go from the low energy reactant to the high energy product. And the exact opposite is happening over here at the exothermic reactions. Energy is released to go from the high energy reactant to the low energy products. These lower energy products are more favorable to form. In this demo, the forward reduction reaction requires energy input from the form of light.
With me here, I have a solution with thionine, sulfuric acid, and iron 2 sulfate. It's a pretty purple color because of the thionine.
Like we said earlier, the reduction of thionine is an endothermic reaction, which means that it is very unfavorable and will require a source of energy for it to happen. For this demo, we're going to use an overhead projector as a source of energy.
Let's see what happens when we put the purple solution under the light.
As you can see here, the purple thionine solution is becoming clear. This means that the iron ions from the iron sulfate are starting to reduce the thionine.
I see why we had iron sulfate and thionine, but why do we need sulfuric acid?
This reduction with intense light can only take place under acidic conditions, so we needed to add an acid solution to make an acidic environment.
As you can see, the solution is turning back to purple. But how does this happen?
This reaction is definitely reversible. It looks like taking energy away, which is light in our case, reverses the reaction.
If we flip the graph from earlier, we see that the reverse oxidation reaction is exothermic and favorable.
Alright guys, that's all we have for today.
We'll see you next time for another
Demo of the week. Bye!